RBMK, reactor Bolshoi Moshnosti Kanalny, plants are single-circuit nuclear power plants built exclusively on the territory of the former USSR. RBMK is the Soviet alternative to the LWGR, light water-cooled graphite-moderated reactor. It is a water-cooled and graphite-moderated boiling water reactor without a pressure vessel and without containment. The fuel assemblies, consisting of pellets of lightly enriched uranium dioxide, are stored in mutually independent technological pressure channels. Vertical technological channels pass through circular holes in graphite moderator blocks. The bulky core is located on the lower shielding plate, surrounded by a lightweight cylindrical body and sealed at the top by the upper biological shielding plate. Ordinary water flowing through the technological channels is heated to saturation temperature in the lower part of the core by the heat from the nuclear reaction in the fuel. The water boils in the upper part of the core. The resulting water-steam mixture coming out of the individual channels at the top is fed into large separator drums through a system of pipes. Here, the water and steam are separated by gravity. The saturated steam is piped from the drums directly to the plant's engine room. First to the high-pressure section of the turbine, and from there to the low-pressure sections through a moisture separator. The steam-spun steam turbine drives an electric generator which produces electricity by electromagnetic induction. The steam condenses in the condenser below the turbine and is transported back to the bottom of the separation drums as feed water after regenerative heating and degassing by pumps. The feed water is mixed in the drum with the water separated from the water-steam mixture, and together is fed through a connecting collector to the intake of the large circulation pumps. The discharge from the pumps is routed to the feed manifold, from which a system of thinner tubes continues to each of the reactor technological channels. The cooling water is thus brought under the core and rises up through the individual channels while being heated and boiled again. Instead of some of the fuel channels, there are channels in the reactor in which the boron-containing control rods move. By inserting them into the core, the amount of neutrons is regulated. The control rod drives are located above the core in the upper containment structure of the reactor hull. Most of the heat released into the fission reaction is dissipated by cooling water. A considerably smaller portion, released in the moderator, is removed from the graphite by a circulating mixture of nitrogen and argon. Spent fuel assemblies can be replaced in the RBMK reactor at full operation by means of a special loading machine moving in the reactor hull. During the exchange, the loader is driven to the specified coordinates, hermetically connected to the channel, and after pressure equalization and release of the channel seal, the spent fuel assembly is pulled out and a fresh assembly is inserted in its place. Power plants with RBMK boiling reactors are single-circuit, which allows for cheaper construction of units and more efficient use of the heat generated. On the other hand, a significant disadvantage of these reactors is their instability. Following this serious accident at the fourth unit of the Chernobyl power plant, the construction of further RBMK reactors was abandoned, and several units still in operation are being gradually decommissioned as planned.